Our atmosphere is a delicate, life-giving blanket of air that surrounds the fragile Earth. In one way or another, it influences everything we see and hear. It is intimately connected to our lives. This chapter will discuss the Earth and its atmosphere.
Morning, ladies and gentlemen. My name is Rafael Kevin Ainagal, and I will be discussing the first chapter of Meteorology, the Earth and its atmosphere. The study of the atmosphere has greatly improved because of the scientific method. The scientific method is the reason why in atmospheric science we have discovered weather forecasts. So we can see satellites or satellite visualizations of a certain map. We can see typhoons and hurricanes. At the same time, we can even easily access them on our cell phones. The Earth's source of energy, together with other planets, is the radiant energy from the sun. However, this radiant energy is very harmful to the creatures. So, this is the reason why the atmosphere is there to protect the Earth. The Earth's atmosphere is a layer of gases surrounding the planet. The Earth is surrounded by a blanket of air, and that is actually called the atmosphere. Now, what are the purposes of atmosphere? First, it absorbs the energy from the sun. It protects us from high energy radiation. The atmosphere protects and supports life as well. It burns incoming meteoroids. To define atmosphere, it's a gaseous envelope that comprises mostly of some gases like nitrogen and oxygen, with small amounts of other gases such as water vapor and carbon dioxide. Here is the composition of today's atmosphere. As you can see, we have nitrogen and oxygen, which contains the bulk of the percentage of elements of the air. So nitrogen comprises 78%, oxygen 21%. The third one is argon. Now it's closely followed by carbon dioxide and water molecules. The Earth's atmosphere is made of mixture of gases called air. So we have here nitrogen, oxygen, argon, and carbon dioxide as mentioned. Now the breath of air is actually averaging to 1 liter. At sea level, there are roughly 10 to the 22nd power air molecules in a liter and 10 to the 44th power molecule in the atmosphere. Now, here are the common gases that we can find in the atmosphere. The largest one, or the largest bulk, is from the nitrogen, which is 78%. It is removed from the atmosphere through the processes done by bacteria in the soil. Also, um, it is taken also by planktons to fortify the ocean's food chain. Well, it is returned to the atmosphere mainly through the process of decaying of plant and animal matter. Oxygen, on the other hand, is removed from the atmosphere when organic matter decays. When the oxygen combines with other substances, producing oxide through the process of oxidation. Taken from the atmosphere also during breathing, as we take in oxygen and we breathe out carbon dioxide. In addition to that, oxygen is produced by plants and other organisms with chlorophyll through the process of photosynthesis. As you can see, this is the nitrogen cycle. So mostly nitrates are recycled through decaying of plant matters. And as you can see, it is also utilized by plants and other bacterium. The oxygen cycle is the same with the cycle with carbon dioxide. So it's a combination or it's an interchange between the two. Now, the third one, we have water vapor. It's actually a potent greenhouse gas. Why? Because it absorbs the outgoing radiant energy instead of releasing it to the air. Well, we actually use these radiant energy during storm and typhoon. And the water vapor has a role in heat energy balance. Carbon dioxide, 0.04%. It enters the atmosphere mainly from the decay of vegetation, volcanic eruptions, exhalations of animal life, and also from the burning of fossil fuels and deforestation. Its removal is through the process of photosynthesis, plants take in carbon dioxide and release oxygen. It's also a potent greenhouse gas, and as this increases in concentration, the surface temperature of the Earth also increases. Other greenhouse gases includes hydrocarbons like methane, nitrous oxide, and CFCs or chlorofluorocarbons. Well, the CFCs usually is the culprit for the destruction of our ozone in the stratosphere. The ozone is also the one that shields us, humans and other creatures, from the harmful ultraviolet ray from the sun. Other pollutants include nitrogen dioxide, carbon monoxide, and hydrocarbons. They are highly poisonous substances that, when inhaled, it can cause death. Now let's discuss air pressure and air density. The amount of force exerted over an area of surface is actually called atmospheric pressure or air pressure. So as you can see, as the height of the area increases, the atmospheric pressure also decreases. So it's inversely proportional. Like when you go on sea level, it's the pressure, the air pressure there is actually very high. But if you go up, like in mountains, the atmospheric pressure decreases. Here are the layers of the atmosphere. The atmosphere has four major layers. We have the thermosphere, the mesosphere, the stratosphere, and the troposphere. Starting from the bottom, we can start with troposphere, followed by stratosphere and mesosphere, and lastly the thermosphere. Taking a look at this diagram, we can see that the temperature usually is um, decreasing as we reach some parts of the atmosphere, and then it also suddenly increases afterwards. These are the usual materials or things that we can find in each level of the atmosphere. Now let's start with the troposphere. It's the lowest and the thinnest layer. Of course, this is 90% of the mass of the atmosphere. The temperature decreases with altitude. This is where the weather occurs. The air is warmest at the bottom of the troposphere near ground level. Higher up, it gets colder. The boundary between the troposphere and the stratosphere is called the tropopause. Now, airplanes fly on troposphere layer. Now, let's go to stratosphere. This is the next layer after the troposphere. UV radiation is absorbed at this level. The temperature increases with altitude. No weather occurrence at this part. So, no air mixing also in this layer. It contains high level of ozone. Well, as I mentioned earlier, ozone layer is the one protecting us from ultraviolet ray from the sun. The upper boundary is called the stratopause. The temperature, which changes slowly in stratosphere, is also stopping to change here. Okay. Air balloons can go up to stratosphere layer. Let's go to the coldest part of the atmosphere, the mesosphere. Usually meteoroids get burned in this layer. It's around negative 100 degrees centigrade. The temperature decreases as altitude increases. The boundary between the mesosphere and the next upper layer is called the mesopause. Now let's have the next one, which is the thermosphere. Above the mesosphere, the thermosphere can be found. It's usually extends to almost 500 kilometers in height. This is the hottest layer. The temperature increases with altitude. The upper atmosphere or thermosphere is called the ionosphere. Um, it extends from 80 to 550 kilometers above the Earth's surface. The ionosphere absorb radiation from the sun and become electrically charged. Electrically charged particles are called ions, hence the name ionosphere. This one readily absorbs solar radiation. The temperature can go as high as 1500 degrees centigrade. The good thing is it reflects radio waves. This is the reason why we can hear signals from radios at this level, and we can hear it in Earth. International space stations are present in this layer too because of that ability. These are the things that we can find in the thermosphere layer. Now, what about auroras? Well, we have two forms of auroras. We have aurora borealis and aurora australis. An aurora is a natural light display in the sky, usually of greenish color but sometimes red or blue. This phenomena usually occurs in areas known as the auroral zone near the North Pole and the South Pole. Aurora is caused by the collision of energetically charged particles with atoms in high altitude thermosphere within our atmosphere. The sun contains particles which gets pulled into the Earth's magnetic pole fields. As they accelerate towards the Earth, collision occur between these ion particles and nitrogen and oxygen atoms in our atmosphere, releasing energy in the form of amazing aurora lights. Now, to have a summary, these are the layers of the atmosphere from the troposphere to stratosphere to mesosphere and lastly the thermosphere. Some scientists would actually include exosphere as the last part after the thermosphere. So, to discuss, the four layers of the atmosphere include the troposphere, where we live. The stratosphere is the one that contains the ozone layer. The mesosphere is where the meteors burn. That's the coldest part. And lastly, the thermosphere is where our satellites orbit the Earth. This is the hottest part. Continue our discussion on the first chapter of meteorology. So, to discuss meteorology, we can simply say that it's the study of atmosphere and its phenomena. Well, the phenomena include weather and climate. It came from the Greek word meteoros, which means high in the air. A meteorologist is a person who has completed the requirements for a college degree in meteorology or atmospheric science. Now, what's the difference between weather and climate? Weather is the condition of the atmosphere at any particular time and location. It's defined as temperature, cloudiness, precipitation, and wind speed and direction. Climate, on the other hand, is the representation of daily and seasonal weather events over a long period of time. The distribution of the weather element throughout the season or year, departures from long term averages, anomalies, and extremes in weather are also important aspects of climate. Now, to simply understand, weather often dictates the type of clothing that we wear. Like, for example, today is windy, so we wear jackets. While climate influences the type of clothing that we buy. For example, the current climate is very hot. So the hot climate, then we wear or we buy clothing that are light like cotton. Climate determines when to plant crops as well as what type of crops can be planted. Like during the dry season, we can plant watermelons. Weather, on the other hand, determines if these same crops will grow to maturity. Like when you plant the seeds of watermelon, suddenly there's kind of a storm during the dry season. So because of that, we can easily recognize that this will flood away the seeds that we planted. Let's take a look at this video.
Could it be a nicer day for a hike? I don't know what you're bringing all that stuff for.
Hey, you never know when the weather's gonna change. Gotta be prepared.
RJ, it's like the sunniest day so far this summer. No way it's gonna rain.
Right now it's sunny, but I'm telling you, weather is the condition of the outside air or atmosphere at a particular time and place. It can change quickly. Ever hear of braving the elements?
I think so.
Well, it means the elements of weather. Air temperature, air pressure, humidity, wind, clouds and fog, and precipitation like rain, snow, and hail, those are all elements of weather.
RJ, I really don't think the weather's gonna change right now.
Oh yeah? I'm willing to bet you that 2 elements of weather are about to change as we hike up this hill.
I'll take that bet. What's gonna change in 5 minutes?
How about temperature and air pressure? Even though it's sunny, the temperature of the air can still change. As we hike up the hill, it's gonna get cooler because we'll be at a higher altitude or elevation. The higher we go, the cooler the air is and the higher the air pressure.
How much cooler can it get?
Well, this hill isn't very high, so it won't get much colder. But if we were hiking something like Mount Everest, we'd be talking about seriously freezing temperatures.
Whoa. So the higher we climb, the colder the air temperature?
Yep. And as we climb, it's gonna get windier too. Cool air is heavier than warm air, and it sinks. As it sinks, it gets warmer. Warm air rises back up again. When air sinks and rises like that, it causes winds. The higher we hike, the cooler and heavier the air is, and the faster it sinks.
And the faster air sinks, the faster the wind blows?
You got it.
So it gets a little cold and my hair gets messed up. I can handle it.
Okay, then what if it rains?
Rain? The climate is very nice today.
Sam, climate has to do with the usual kind of weather in a certain place over time, not on a particular day. Check it out. There are different climate zones all over the world. The main differences between each climate zone are precipitation and temperature, and those two things make the plant and animal life of each climate different. Climate is the overall weather pattern of those two elements in a certain area over time.
So weather changes day to day, but climate has to do with the big picture. And the weather today is picture perfect.
It is a warm, sunny day, but this heat means more moisture is being evaporated into the warm air. As that warm air rises higher, it cools, and that moisture turns back into droplets of water. When that happens, clouds form.
But clouds can't hurt us. They're big, fluffy puffs of air.
They're big, fluffy puffs of cold air, ready to burst with rain.
You seem to know a lot about the weather today, RJ. Did you watch the weather on the news or something?
I always check the weather. That weather guy is called a meteorologist, and his job is really important. Meteorologists study weather patterns to try to predict future weather.
Who needs a meteorologist when I have you?
I think I felt a drop.
Did not? Come on, you have to be kidding me.
What'd I tell you?
You told me, all right. Weather describes the condition of the outside air of a place at a certain time. And at this certain time, it's raining. But like you said, many factors affect changes in weather. Weather changes every day, and climate describes the weather of a place over time. Climate zones explain weather patterns and plant and animal life of particular areas. And I think we should move to a climate where it never rains.
Oh, come on. A little rain never hurt anybody. Lucky for you, I brought an extra raincoat.
Thanks. I guess we can still hike, thanks to all your rain gear. But how am I supposed to paint?
Watercolor?
Thank you very much for watching the video.